Hello my dear children of class 11 science. Today we do continue with the chapter that we started even from yesterday's class. Okay, that is superposition of wave number 2, and this is basically stationary wave or standing wave. And basically in this chapter we learn vibration of air columns. Okay, now in today's class we basically start with the equation of a stationary wave. Because in the last class, that was the class which was held yesterday. Okay, we did what is stationary wave, what is bounded medium. Okay, close or open boundary or closed boundary. Okay, then after we learn the characteristic of stationary wave, followed by node, antinode. These are the topic terms we learned in last class. Now in today's class we derive the equation of stationary wave. Now stationary wave as is also known as standing wave, but this wave is basically formed by the superposition of two plane progressive simple harmonic wave which move with the same amplitude. Okay, but the wave which superpose are nothing but the incident wave and the reflected wave. Okay, now in order to derive the equation of stationary wave, let me just start with the progressive wave, plane progressive wave, and that wave I consider that traveling in a particular direction, okay, of x-axis. The particular direction x-axis means it can be either positive x-axis, it can be negative x-axis, but I consider the wave is propagating or producing in a positive direction x-axis. That means a plane progressive wave, say of amplitude a, small letter a, is traveling with a speed, and that speed is b along what axis? Say positive direction. What axis? X-axis. So this wave will be the incident wave. This will be the incident wave. Now this wave has an equation, and see children, we have done the equation of plane progressive wave. So I write down therefore the equation of incident, let me use the word incident plane progressive wave, So that means this wave is incident on the on the rigid support or on the open surface, okay, boundaries where this wave is incident, and this wave has an equation also. The equation of incident plane wave is given by yi. This I implies the displacement equation of plane progressive wave or plane progressive incident wave. That means yi equals to what? I write down as a sine 2 pi by lambda, okay, 2 pi by lambda bracket b into t minus x. Okay, so this is one of the equation of plane progressive wave, but I am writing as yi because I have mentioned out here that the equation of incident plane progressive wave, wave, and that equation is given by yi equals to a sine 2 pi by lambda bt minus x, where a is the amplitude of the wave, lambda is the wavelength of the wave, b is the speed in which the wave propagates, and x is the distance in which this wave goes and make the particle to displace. Okay, so this is the equation of incident plane wave. Now if the same wave get reflected from our free boundary, okay, boundary, and the reflected wave advance in the direction? Negative direction. Axis? X-axis. I mean, this is the wave which is propagating along positive direction x-axis, say this direction. After reflected incident on the free boundary, okay, the light so wave get reflected, and if the wave get reflected and advance in the negative direction of x-axis, in that case also the wave propagate in the form of progressive wave also. So for that also we can write the equation, and the equation of reflected plane progressive wave is given by yr. Okay, just mentioning this way, yr. This small letter r means the equation for reflected plane progressive wave, and the equation will be same as this, but with what sign? Plus sign. So look at it. It will be a sine 2 pi by lambda bt. Now this will be plus x, because when the wave progress in the reflected negative direction x-axis also, the amplitude of wave remains same. That means progressive wave is such a wave, throughout the motion, okay, the wave propagates, the amplitude remains same. The wavelength is also same, travel with the same speed even in the negative direction, and negative direction, that's why I'm putting with what sign? Plus sign. This is with negative sign. This is the wave advancing in the positive direction x-axis, and this is the wave which is advancing the negative direction what? X-axis. Sorry. Now children, if you look at this diagram which I have already drawn, okay, this is the diagram that explains the plane progressive wave which is being reflected from the free surface, free end, or also called open end. Okay. Now when a wave propagates on a free reflecting surface, along the free reflecting surface, that wave gets reflected, okay, from the surface. Okay. Now these two diagrams, if you see, is nothing but a diagram for the reflection of sine wave and the reflection of cosine wave, because sine and cosine are the two functions which are complementary to each other. That means they are differ by angle of 90 degree. That's why the nature will be same, but they differ by 90 degree. Okay. Now the equation which I have written is for sine function. So that means this equation which I have written is for this particular graph. Okay. So yi equals a sine 2 pi by lambda bt minus x is the displacement of the plane progressive wave when the wave propagated in the positive direction what axis? X-axis. And this wave is incident on the free reflecting surface. Free reflecting what? Surface. So when wave propagate in this manner, so AB is the wave, okay, which is incident. This is the incident wave, okay. Then after the reflection, the wave propagate in the same phase. That means BC is the reflected wave. BC is the what? Reflected wave. This is the incident wave. BC is the what? Reflected wave. And this reflected wave is expressed by the equation. You can see it is YR equals to A sine 2 pi by lambda BT minus X. Now this plus sign means the wave reflect back after the free reflecting surface in the same phase. In the what phase? Same phase. Okay. So if they reflect back in the same phase, means there is no change in the phase and the wave return in the same way as it would have advanced in the absence of what? Reflected wave. That means, see, wave is advancing from what? Advancing from the what? Positive displacement of what? This line. And the wave return back even from the positive displacement of y. Okay, displacement of what? X and positive displacement of y only. This is positive displacement, this is negative displacement. See, wave is advancing, that is incident from the positive displacement y axis on the free surface, and when it return back, when it get reflected, it also returning back or advancing from the positive direction what? Y. That means in this case what happened? There is no change in the phase. That's why yi is given by a sine 2 pi by lambda y bt minus x, and yr is given by a sine 2 pi by lambda bt plus what? X. The only thing that changes in the sign, minus x can be written as plus x, because the direction of direction of propagation of wave changes. That means it is propagating x-axis, that's why it is minus x. It is positive negative x-axis, that's why it is plus x. Okay. So this is the case of the reflection of plane progressive wave from this free reflecting surface or free end. Now this diagram which I have drawn already is also the plane progressive wave, but for which function? Cosine wave. So just to show you, okay, cosine wave advance in opposite direction. See, if sine wave advance in this way, cosine wave advance in this way. Okay, so that it reflected in the same manner. Okay, if it is advancing from the opposite direction, displacement y-axis, it gets reflected back and advance in the positive direction y-axis, but with this manner. That means this is also the diagram, okay, that makes the reflection of cosine wave. But children, we deal only with outer with sine wave. Now if the same plane progressive wave which were inciding in the positive direction, okay, and if this plane progressive wave get incident on the rigid boundary and get reflected from a rigid boundary, but what boundary now? This time the rigid boundary, then the equation of reflected wave can be given by yr, okay, and this time it will be equals to minus a sine 2 pi by lambda with bracket bt minus what? X. So look at the equation, yr equals to minus a sine 2 pi by lambda bracket bt minus x. This is the reflected plane progressive wave which is get reflected from the rigid boundary. Okay. So now in this case, The wave, the plane progressive wave, as you can see, is advancing in the positive direction x-axis, okay, in the manner, and this is also the example of what? Reflection of which wave? Reflection of sine wave. This is also the reflection of what? Sine wave. And this waves, plane progressive wave expressed by sine function, is advancing in the positive direction x-axis and get reflected from the rigid reflecting surface, like the string whose one end is tied to a rigid support act as a rigid reflecting surface. So once it gets incident and get reflected back, it reflected back in the opposite phase. See, because it's incident from the positive displacement y-axis, but once it gets reflected, it reflected from the negative direction of what? Y-axis, displacement y-axis. That's why we have put what sign? Minus sign. So this minus signs indicate that the reflected wave has opposite phase to incident wave. That's why the phase changes in this case, because in this particular case what happened, the light get reflected, plane progressive wave get reflected and propagate in this direction, but from the negative displacement of y-axis. See, negative displacement of y-axis, starting from negative expression. That's why what sign we have substitute? Minus sign. So that's why yr is given by a minus a sine 2 pi by lambda bt minus what? X. So under this case, the wave undergoes a phase change. And how much phase change has done? 180 degree. Okay. This side displacement is positive, this side displacement negative, means what is the due to displacement in which the wave are propagating are opposite to each other. So what is the difference in the phase? 180 degree or 1 pi degree, pi radian. That's why you can see in the expression of this yr, there is a what sign? Minus sign. And this minus sign, as I said, it indicates that the wave undergoes a phase change of how much? Pi or 180 degree on the reflection from a rigid boundary or rigid end. Okay. Now these two waves, whether the wave reflected from the rigid boundary or whether wave reflected from the free boundary, these two waves will always superpose each other. And when these two waves superpose each other, then by the principle of superposition, we always get the resultant displacement. Okay, and that resultant displacement is given by y equals to yi minus yr, yi plus yr. So now what I do, I calculate the resultant wave displacement. So as I said already, we follow the principle of superposition, and that principle of superposition measures the resultant displacement, that is y equals to yi plus yr. Okay, now this can be applied for any of the wave, means any of the reflected wave, whether it is for the reflection takes place from the free boundary or the rigid boundary. Okay, so let me just do with the reflection from the which boundary, say rigid boundary. So let me just substitute the value. Now yi, you know yi means what? A sine 2 pi by what? Lambda bracket bt minus x. Now plus yr, so I take this one, yr means minus a, so but I write on plus into minus is what? Minus. So I am writing minus a sine 2 pi by what? Lambda bt minus what? X. So this equation which I am following out here, this is bt plus x, and this is also bt plus x. I am so sorry for this, because in the negative direction, this also sign will change, and this phase also changing when the wave get reflected from the rigid surface. That's why it is plus. Okay. Now this is from rigid support, rigid boundary. So this is the reflection of which takes place from which boundary? Rigid boundary. Now in order to solve, let me just take common. Okay. So before I take commons, I write this equation in like this also. Like I write this quantity first. I write minus a sine 2 pi by lambda and bt plus x. Then I write on this plus a sine 2 pi by what? Lambda bt minus what? X. Now I take common minus sign, minus a. If I take minus a common, so inside the bracket it will be sine 2 pi by lambda bt plus x minus, now plus, minus into plus means minus. If you take minus sign common, so it will be sine 2 pi by lambda bt minus what? X. So this is what? Y. So y is coming this much. Now in this particular relation, I am going to use one of the formula of trigonometry for multiple angles. Okay, and the formula is sin A minus sin B. This is one of the formula, important formula. Sin A minus sin B equals to 2 cos A plus B by 2 sin A minus B by 2. So this is one of the important formula in trigonometry of multiple angles. So just considering the same way, sin, I consider this whole quantity as A, and I consider this whole quantity as say B. Sin A minus sin B. So I'll expand this by this relation, 2 cos A plus B by 2 and sin A minus B by 2. Now after using the formula, we can write the expression as y equals to minus A is already there. The formula is 2 cos A plus B by 2. So cos 2 pi by lambda bt plus x plus bt by lambda bt minus x by 2. Similarly, sin A minus B by 2. Sin A means this much, minus B means 2 pi by lambda bt minus x by 2. Now we can further simplify this expression, okay, and we write down as minus 2a cos. Now in the expression, let me open the bracket. It will be 2 pi by lambda bt, okay, bt plus 2 pi by lambda x. So I have opened this bracket, plus again 2 pi by lambda bt minus plus into minus minus, so it will be 2 pi by lambda what x whole divided by what 2. This is cos only. Now we do continue with sin also. Similarly, sin equals to, I do in the similar manner, 2 pi by lambda. Now this 2 pi by lambda into bt I multiply, it will be bt plus again 2 pi by lambda with x, 2 pi by lambda into x. Now minus into plus is minus, so minus 2 pi by lambda into bt. Now minus into minus is plus 2 pi by lambda into x whole divided by what 2. Now see, we can do the cancellation out here. So this 2 cancel out and this 2 cancel out. Now see what is remaining, minus 2a cos. Now this 2 quantity will be added. So added means 2 into 2 pi by lambda into bt, okay, whole divided by 2. Okay, and this is sin. This 2 quantity will also be added. So I write on 2 into 2 pi by lambda into x by what 2. Now this 2 and 2 cancel out, this 2 also cancel out. So now we are getting the expression, okay, as minus 2a cos 2 pi bt by lambda and sin 2 pi x by lambda. Now see the expression that we obtained, that is y equals to minus 2a cos 2 pi bt by lambda. So okay, let me write this in bracket, and sin 2 pi x by lambda, 2 pi x by what lambda. So this is the relation that we obtained, okay, when we had done this for what for rigid boundary. This is for the rigid boundary, when the reflection takes place from the what boundary, rigid boundary. But I'll write the same relation even in this manner also. So I write down minus 2a, I write this quantity first, sin, I write down sin 2 pi x by lambda, I write down, then I write down cos, okay, and this is 2 pi t, small t by capital T. Now what I did out here, that I replace this capital T by b by lambda, okay, because time period, this is time period, okay. Now this time period, actually sorry, 1 by t, sorry, this is 1 by t, so please do correct out here, 1 by t equals to b by lambda, okay, because 1 by t means actually what, nu, this nu is frequency, that is b by lambda. So frequency means speed by wavelength, then frequency is 1 by t, so 1 by t means b by what, wavelength by t, okay. So the relation, that is b by lambda, I replace by what, this b by lambda I replace by 1 by t. That's why it is cos 2 pi t by capital T. Okay, and I'll give this as equation number 1. Now as for this equation 1, you see that in this equation, okay, as the argument of trigonometrical function is involved, okay, as the argument of trigonometric function involved in equation 1 are not in the form of say bt plus minus x. That means it does not represent a traveling harmonic wave. It does not represent a traveling harmonic wave. And this simply represent the what? The equation of what? Stationary wave. That means it represent what? It represent the equation of what? It represent the equation of stationary wave. Okay, stationary, or also called what wave? Standing wave. Because in this equation, this displacement and trigonometric function is not involved with this bt plus minus x and all. So it's simply with 2x, 2 pi lambda, 2 pi x by lambda and 2 pi t by t. Okay, that means this equation is actually the equation of stationary wave. Means the displacement of every particle medium remain fixed. Okay, that means the wave does not represent as a traveling wave. It represents a standing or stationary wave. So one of the first equation we obtained, the equation of stationary wave for the wave reflecting from the rigid boundary. But you know the wave can even reflect from the what? Free boundary also. So finally, you can even write the same equation of standing wave, stationary wave, if the plane progressive wave get reflected from a free boundary. Okay, free boundary, and in that case, the equation will be same, but minus become plus, minus become plus. The same 2a cos, I've written sine 2 pi x by lambda we had written in case of reflected boundary. Now it will be cos 2 pi x by lambda for rigid boundary, free boundary. Similarly, cos 2 pi by t, small t by capital T we had written for reflected boundary. Now cos will be what? Sine 2 pi t by capital T for rigid free boundary. That means if you look at this equation, just compare these two equations, minus become plus, sine function is replaced by cosine function, where the other quantity remains same. So these are the two equations of stationary wave for the wave propagated and is reflected from the free boundary as well as the rigid boundary. Now in the next YouTube video, we do a very important topic that is called the mode of vibration of air column in organ pipes.